And welcome again to Math County. So in this video, we are just going to solve some problems under limits, and you would have watched the videos prior to this video that I made to be able to understand this video better. So go onto my bio and then find those videos and watch. Okay, so let's look at this first example. So we have limit as x approaches 1 of this function, and at f of 1, this function becomes 1 minus 1 over 1 minus 1, and we have 0 over 0. This is indeterminate, right? So the next thing we have to do is to simplify this function, okay? And to simplify this function, say we have lim as x approaches 1, we have x minus 1, and then x squared plus x plus 1 over x minus 1. So this cancels out, and then we have lim as x approaches 1 of x squared plus x plus 1. And this is equal to 1 plus 1 plus 1 if we substitute 1. And then the limit point is 3. Now, let's look at this one which has a quadratic as the numerator. So we need to factorize the quadratic. So to factorize the quadratic, we can choose two numbers, that is -2, -3, such that these two numbers can multiply and give us +6, but add to give us -5. So we have x squared minus 3x minus 2x plus 6. Okay, so here we factorize x out, and we have x squared, x. We have x minus 3. We have x minus 3 minus 2, and then x minus 3 here. Alright, so our factors are x minus 2 and then x minus 3. So you can simply substitute it into the function, and then we have limit as x approaches 3 of x minus 2, x minus 3 over x minus 3. So this cancels out, and then we have limit as x approaches 3 of x minus 2. And you get to write the answer is 1. So our limit is 1, right? Okay, let's consider this third example. Okay, so here, let's just consider this fraction here. So let's say g of x is equal to 1 over x minus 1. Now, let's assume that x is approaching 1 from the right. If x is approaching 1 from the right, let's assume that x is equal to 0.99. If x is equal to 0.99, f of x will be equal to 1.0101. Okay, what if x is equal to 0.98? Then f of x, or f of 0.98, will be equal to what? 1.0104, right? Okay, so clearly, as we approach 1 from the right, the function g of x approaches infinity, right? So g of x approaches infinity as x approaches 1 from the right. Okay, in that case, then we have limit as x approaching 1, x squared minus infinity, and at the end of the day we realize that this function approaches negative infinity. Okay, so the limit approaches what? Negative infinity. All right, so what if x is approaching 1 from the left hand side, right? Okay, so I will clean this side of it and then we'll take a look at that one. Okay, so if x is approaching from the left, then let's just assume some values. Okay, x minus 1. Alright, so let's just assume that we have from the left we have 0.8 x, then f of 0.8 will be equal to 5. And then if we have 0.9, f of 0.9 will be equal to minus 10. Sorry, this is minus 5. Okay, so clearly we can see that as we are heading towards 1 from the left, the value of g of x, the value of g of x is approaching negative infinity. Okay, hence limit at x approaches 1 from the left, 1 over x minus 1 is negative infinity. So if we replace negative infinity into the function, we get limit as x approaches 1 of x squared minus infinity, hence approaches positive infinity. Right, so here obviously the left hand limit and then the right hand limit are not the same, right? So the left hand limit, let's name the right hand limit. Okay, right hand limit was equal to what? Negative infinity, and the left hand limit was equal to positive infinity. Therefore, we can boldly say that the limit does not exist. Right? Okay, so let's go on to the next example. So let's look at this very simple one. If we substitute 0 into the function here, we are going to be left with a cubed plus 2a minus a cubed minus 2a all over 0. And this will leave us with 0 over 0, which is indeterminate. Okay? Great. So now, what happens when we simplify the function before making the substitution? If we simplify the function, we are going to have, I implore you to do this simplification yourself, and you are going to have limit as x approaches 0, 3a squared x plus 3a x squared plus x cubed plus 2x. Okay, all over x. And this in turn gives us lim as x approaches 0. We can just bring out the x here and say x 3a squared plus 3ax plus x squared plus 2 over x. So this goes, and then we have lim as x approaches 0 of 3a squared plus 3a x plus x squared plus 2. And this in turn gives us 3a squared plus 2 after we substitute x to be 0. Okay, so this is the limit. So the limit point of this function depends on the actual value of a. Okay, so let's look at these ones too. So this is quite simple. We have seen this in the previous example. Okay, so here, if x approaches infinity, okay, you realize that this expression will continue to reduce, okay, and this entire function will go to 0. Okay, so this becomes 1 over infinity, which moves to 0. Now let's look at this one. So here we have a rational function. So what's a rational function? A rational function is just a fraction whereby the numerator and the denominator are polynomials. Okay, so here what we can do is we can simply divide each term of the fraction by the highest power of the variable. So here we can say lim as t approaches negative infinity, we have 4t squared over t cubed minus 3t over t cubed plus 1 over t cubed all over t cubed plus 1 over t cubed. Right? So here, clearly we can see that as t approaches negative infinity, the t cubed moves to negative infinity quickly, okay? Before that, let's just simplify the fractions first. So this gives us 4 over t minus 3 over t squared plus 1 over t cubed all over, okay, so this is t over t cubed. So we have 1 plus 1 over t cubed. Okay, so this goes to 0, this goes to 0, this goes to 0. We have 0 plus 0 plus 0 all over 1 plus 0, which is equal to what? 0 over 1. And finally, this is equal to 0. Okay, so we'll leave the video here and then continue in the part 2 of this video. Thank you, and I'll see you in the next video.